Section 5.1, Basic Concepts of Probability, Video 7. At the end of the previous video, I asked you what you thought the sum of all the probabilities was. When I asked you that, I was prepping you for what are known as properties of a probability model. So let's just take a look at these four properties, which are currently incomplete, so we'll be filling them in just a minute. Property number one, for any event E, and I actually meant to go ahead and write, nope, not on that one. For any event E, what can we say about its probability? Well, it's kind of a vague question, but once you hear the answer, it's going to make perfect sense. The probability of any event E will always be greater than or equal to 0, but at the same time will be less than or equal to 1. Why is that? Because probability is the percent of the time we can expect something to happen. Well, it can't happen less than 0% of the time, nor can it happen more than 100% of the time. As decimals, 0% is just the number 0, and 100% is just the number 1. Another way of saying this is all probabilities are between 0 and 1 inclusive. Now, property number two. If an event E cannot occur, and here's what I meant to write prior to starting the video, what is its probability? And the same thing for property 3. If an event E must occur, what is its probability? Well, think about it. If something cannot occur, what percent of the time would you expect it to happen? 0% of the time. An event that cannot occur is sometimes called an impossible event. Imagine that. Now, on the flip side of that, if an event E must occur, in other words, if it must occur all of the time, then what percent of the time do we expect it to occur? Well, 100% of the time. And as a decimal, 100% is the number 1. An event that must occur is sometimes called a certain event. Sometimes it's called a sure event, like a sure thing. So it is possible for probabilities to assume the extreme values of 0 and 1. If it can't happen, its probability is 0, but if it must happen, its probability is 1. Now let's go back to the end of the previous video where I ended with a cliffhanger. Did anybody figure out what you got when you added up all of those percents? You should have gotten 100%. And the reason is the fourth property of a probability model. This one, the notation's a little bit intimidating, but it's not that bad. All I did here in this set is list all the possible outcomes generically, which is why I used a capital O instead of a capital E. So O1, O2, and then some ellipses to say there's more in the middle. And since we don't know how many outcomes this would actually have, I left the last subscript generic by calling it ON. So we're saying that there's n possible outcomes in an experiment. But if this list is all of the possible outcomes for an experiment, then what is the sum of all those probabilities? You might remember we had sigma notation representing the sum of some things when we had formulas for mean and standard deviation before the first test. This one's a little bit more specific because when you take a sum, you can say, well, I want you to add all of these expressions, but there's going to be one place where a number is going to change. Now, the way you can recognize where that place is by looking at the bottom of the sigma where it says I equals 1. This means we're going to take turns letting the I equal the number 1 all the way up to the number n. So we would let it equal 1, in which case we would get the probability of outcome 1. The sigma means add. And then we would let I be the next number. So the probability of outcome 2. All the way up to the last one, which we don't know, so generically we called n, plus the probability of outcome n. Now, that's not the answer to what that sum equals. That's just explaining what that sum means. So what do you think the sum of all the probabilities are for an event, for an event's possible outcomes? Well, it was the same as it was at the end of the previous example, 100%. Or 1. In fact, I want to go back up to the previous properties and state them in terms of percents as well. If an event cannot occur, its probability is 0%. If an event must occur, its probability is 100%. And for any event, the probability is always between 0% and 100%. So you can always think of probability in terms of decimals or in terms of percents.